Okay, Bismillahirrahmanirrahim. Rabbi shrah li sadri, yassir li amri, wahlul 'uqdatan min lisani yafqahu qawli. In the name of Allah, the most beneficent and merciful. Today we'll start a new topic, and the topic is about aggregate. As introduction, I have told you that aggregate forms a major portion of highway road construction, be it a hot mix asphalt or be it a rigid concrete. Though in hot mix asphalt, we use around 95 to 96% of an aggregate in a mix, while in a cement concrete, it may be around 85 to 82% of its contribution. So, let's see the aggregates and how it is defined, how it is produced, how it is graded, and how it is blended. All this will be the part of this course, and we go one by one. As a matter of fact, soil is also a rock. So when we say an aggregate, we can refer to all unconsolidated material in the earth crust, all material above the bedrock. And when we say an aggregate, we talk about all those mineral particles that are present in a soil is an aggregate. And specifically, those who have larger in size, that is a granular soil group. It can be a gravel, sand, and silt. Technically, we call soil, locally we call soil as a mitti, but what I mean by mitti is something that is passed over minus 200 C or past 200 C. All that retain on number 200 C at least is an aggregate. It can be of obviously of great if it is a larger size, then it can be gravel, or if it is if it is of smaller size, then it's silt. So when we say granular soil group, these aggregates are formed due to physical weathering that we have discussed in our soil section as well. There is action of frost, water, wind, glaciers, plant and animals, particles transported by wind, water, ice. Soil that forms are called granular soil types. Grains are similar to the original bedrocks. Then there are particles, obviously, that are larger than clays. Particles tend to be more or less spheres, cubes, spherical in shape, but less spherical as compared to the clay particles. They are, cubical in shape, and if it is prismatic, that's very good. But normally, when we talk about the aggregate, we talk about the cubical aggregates, those who have an angular faces, and that is also a desirable highway material as if you use in construction of highways. Why I say a desirable highway material? Because though in the building construction, we also use this types of aggregate, angular aggregates, and just also there we have also like to have that cubical or something like angular aggregates. But then in part of lean concrete, we can use this round gravel or pea gravel as well. But these type of pea gravels, or say the rounded aggregates, they are not desired in highway construction. In highway construction, we always go for a cubical aggregate or an angular aggregate. As we say, this is a bound water aggregates or something. They don't bind water as compared to the overall mass. The percentage of the binding with water is less. If it is more, then it's a problem. Why? Because it means they have more porous, and more porous means it may be less denser, and less denser would mean it may not be very solid, it may not bear the traffic load. So that's why We are very interested in it's a we like to be porous. We like to have be permeable, but it's to a very small content, like 0.5%, maybe 0.6%, at most 2%. But if it is more than that, then we are talking about something that we don't like. This is how this the soil particles. There is a dry density and there is a zero air voids, and this is a curve. You also know how you find the dry density and how this aggregate have different aggregates have high dry density as the other. Obviously, it depends upon the size of an aggregate and depends upon the conceptually. If you have a finer material, then it will absorb more water, and at the same time it may not have a maximum density as compared to a granular material, or say crush aggregate, or something of a higher size of what we call a gravel. It will take less water and then it have a high density, while those who needs more water, they means they are more fine, and this is why. Technically, this is a very simple case. Whenever you have in your gradation, you have fine aggregate, it will absorb asphalt. And if you are coarser type, it will absorb less aggregate. So if you have been asked the thing that you are in mixed design having 4.5% asphalt content, and you have designed 4.2% asphalt content, what should be the gradation? What should be the gradation like? Without going into any technical detail of the mixed design, it's a very thumb rule. If you have two things, if you have higher percentage on asphalt, it means it is a finer material as compared to the coarser material. Now then the technique what we prefer. Normally, we prefer a coarser aggregate, and we have the coarser aggregate will means it will resist more, and will it resist more? It may absorb. It may have a less asphalt content. That's also good, because then you will have a less cost. But again, coarser may not means all things are open graded. Then if it is a problem of honeycombing, as we understand, as we know that in a cement concrete, if there is if there is more voids, then it is very easily breakable. So okay, what we mean when we use aggregate, we talk about every size of an aggregate to be there, but in some proportion. If some proportion is higher, then it will be a problem. So we will talk about this inshallah in the gradation side. But to be just for the sake of comparison, just for the sake of the knowledge, we always have to have aggregate that has got maximum dry density. This is our desire. So as I said, as I was discussing, that in the granular soil, ability to achieve greater densities, they are well graded. Well graded means it has all the graded particles in their group, in their family, what we can say like that. It has a strength, high strength, it is lower permeability, and it has it will technically, it will naturally, not technically, it actually reduce the future settlement. But why does this future settlement? We all know, because the finer the material, the more water it will absorb. The more water it will absorb, it will settle down. And if thing does not absorb water, there are less chances of its settlement. And that's why these improvements dictates the use of aggregate in the pavement layer where wheel loads are greater. Now, in combination with asphalt, cement or Portland cement to form asphalt concrete respectively that I was discussing, this aggregate can be used as a combination, right? It is being bounded when asphalt cement or Portland cement. or to form a concrete. What you know, what we know concrete. We means anything porcelain and finer aggregates. When they are mixed with a binder, it's a concrete. So obviously, when talking about the concrete, be it an asphalt, be it cement, we're talking about those aggregates that are being bounded. Now, and obviously, there are in a roadway structure, in a flexible pavement, or even in a rigid pavement, the sub-bases are not normally bounded. They are unbounded, means they are there without any binding material. They are placed, they are got compacted, and they drive their strength with the grain to grain site structure. Then obviously the aggregates. Actually, we tend to forget always this thing, that when we teach this highway material course, we do not focus on the drainage structure. Actually, the drainage structure also a part and parcel of a highway material. Even the bridges, we don't, highway engineer don't usually own them. Whenever we are discussing this highway roads concept, road construction, we tend to forget those box culverts. We tend to forget about the drainage structure. We try to forget about these flyovers. Actually, they are part and parcel. If they are not there, you cannot. Your highway structure is incomplete. So obviously, those aggregates, if they are also made up of those aggregate also contributes in those drainage structure as well. And last but not least, the concrete blocks, the curb blocks you lay while have a pavement. Now let's go to the types, the common types of an aggregates. We have a base, so we'll discuss about these types of aggregate, what are the properties of the aggregates, and the test used to evaluate this property. This is the general trend whenever you teach those aggregates to the students. We discuss these things at large, and then along with these things, there are other things that we will also discuss during this course of lecture. It's very important to know the source. Whenever a highway construction contract is floated, the first thing a contractor asks to himself, whether the bid I am going to give for this construction, for getting the contract of this road, whether I have the source of aggregate that are locally available or not. I tend to, I'm very firm on it, and this is, I think it's a practice. Any contractor that is being that he wants to contribute, he wants to fill that tender, he always have a visit, at least a reconnaissance survey of the area where he would find the maximum aggregate. Because the first thing after the award of the contractor and the mobilization, the contractor is asked to verify the sources from the consultant. The contractor has been given the specifications along with contract document, and he has been asked. Actually, I'm just keep on saying he is, because normally contractors are the male owners. Unfortunately or fortunately, what you can say is he has been asked. There has been this contract document that these are the specifications of aggregate, and before the groundbreaking, he must submit the sources, the verified sources. Not only that, he has to submit the report. What report? The quality of an aggregate. Whether those aggregate that is identifying the source, is it viable enough to fulfill all the specification within the project. The second thing, he wants to know a person whether they are in abundance or not. Because highway construction requires a lot of materials. And if a person identified that this is a source, but he must know what are the production capabilities of that source, how much material he will get from that source in a total or on the daily basis as well. And this he has to verify with the consultant before going to the project, execution of the project. And if he is not able to do it, then there is a problem. The contract may be delayed, and all those delaying and things are like happens. So what a person who was going to go construct a highway, or the consultant we are going to highway, actually, as a consultant, we tend to say it's a contractor obligation. So we tend to forget it, but again, we need to verify the sources. Because the quantity is also always known to me. When I wanted a contract, I know that this how much of aggregate I would require in totality. So we talk about where are the sources, whether I will use the natural sand or gravel deposit, whether I'm going to use crushed rocks, whether I'll be allowed to use slag and mine refuse, whether we will use the rubble, or we call it recycled aggregates. Am I allowed? Then the artificial and processed materials, maybe a pulverized concrete and asphalt pavement. Let me just define this pulverized concrete, because sometimes we tend to confuse. It's what is that is normally if you break the concrete, if you demolish the concrete, it will not be of your required. So we some processes make it usable. So that's why we call it pulverizing a concrete. And then also there are other type of recycled and waste materials, in the industry. People try to use it. But, before I go ahead, let me tell you, no one has ever replaced the natural aggregate 100%. The maximum people have gone is 30%. Again, there are reservations, but I can say based on the knowledge and based on the data I have got, I think it's 15% is okay. But more than 15%, then you have to be very specific. So we don't go to the juggle of recycling of aggregate. You are not going to maximum. You are going to get 15%. 85% still you have to go for the natural resources, and even this also have to be changed. This has to be allowed by the consultant. If the consultant has desired that this is 100% aggregate that you are going to use, a natural aggregate, contractor cannot change it unless or until they found that if they use 15%, that's okay. It is accepted by all quarters of the people who are in execution agency. Then you can identify that source. Otherwise, you have to use this natural aggregates. Now, let's have a brief on how aggregate are produced, because this production rate also determines the time lag of your project. And a person has to know the basics of how these aggregates are produced, even though they are very trivial and they are, a very open fact, but still you must have a knowledge of how those aggregates from rock to the finished material, how these rocks are processed. So there are, 5 basic steps. Actually, you don't know. This is what. So actually, there are 5 basic steps. It starts for the extraction, then crushing, screening. Obviously, we need some number 4 passing material. Then we have to send production, and then beneficiation. Means we need a clean aggregate. So we have to do some technique. Simple as we have to do some washing as well. Obviously, there are ways of washing it, but you have to have a final product. You don't want our aggregate to have a dust. Otherwise, it will not allow aggregate asphalt to be bounded to it. So obviously, there should be dust-free beneficiation of this thing. how the aggregates are extracted uh, without the exception of slag. You know what is slag? Slag is the refusal material during the production of an iron or steel. This is also a very good material because that comes from the steel. But again, it's slag. It's its use is very limited. You cannot use 100% of the slag. It can use as recycled material. The other material, it also it improves your road as well, performance of the road. But it should be used uh, with limited applications. And then there can be manufactured aggregates, most materials for aggregate production. Other than that, the bulk of the material is from the bedrock or unconsolidated deposit. Now, the vast majority of the materials used in mineral aggregates are obtained from surface mined stone quarries or from sand and gravel pits, and also from the river beds as well. And how materials are extracted influence their quality. So when we talk about the extraction, there are types of extraction: stripping, drilling, and short blasting. Let's see those videos of it. Let's share. Let me allow to open those videos that are that are used in striping. In a little while, I'll show you that video. When we say stripping, it is a removal of overburden aggregates from the surface, either by bulldozer and scraper. This phase is overlooked, yet it has a great influence on the quality and variability of the product. Inadequate removal of overburden from mineral deposit often the source of excessive variation in -200 material. It may have a deleterious effect on nearby vegetation and other aspects of mine. Inexperienced equipment operators can easily corrupt good stripping material. Spillage over the working and sloppy phase are not desirable. So this is what we call a stripping, just removing the overburden material either from the excavators or these equipments, as you can see here. The other source, the other way, it's blasting, it's drilling and blasting. Quarries removes from ground to produce aggregate material for use in the construction industry. The first is the blasting. Explosive charges are placed within the holes drilled into the rock and detonated to break and dislodge the rock. This is the same technique as you use to have mining, utility installations, cuts in a mountain, for constructing a road or, for constructing a railway structure or tunnels. We use these techniques, and even the residential basements. Now, once that what happens is that once that rock is blasted, then you can easily gather that rocks, and then you have to do the other things, transpose and process to produce a range of aggregate materials required by the construction industry. But this drilling and blasting is a very, very efficient technique. And it should not be not drilling and blasting, actually blasting. Why blasting? Because the detonator used, you have to cordon out the area that may not be within the city area. It should not be urbanized, heavily congested people living over there. And even around that, you have to estimate what is the capability of your detonator, how much impact that can create, because you may find that aggregates, once blasting, it will be, going everywhere. So one should be very careful in first recommending this thing, and then it's a very it's a very specific science. Not everyone do it, and not everyone wants to experience with it. People have, the area has to be cordoned. This detonation timing have to be, very. It's like sometimes even you are talking about playing with an explosive. So even a person who's trained, God forbid, while installation, he may be accidentally plug on that thing. So it's a very precise technique. It's a very dangerous technique. So though blasting is very common, but still it's a very thing. Unlike drilling nowadays is uh, easy. At least the danger of blasting an aggregate uh, as compared to the blasting, it's very less. But then the problem again, if you are living in an area, urbanized area, those hammer tends to be, it's look like it is someone is stepping on your head. So again, this is a very specialized technique. It's not very easy to cut the rocks, and then it's a drilling, and it's if it is an igneous rock, then you are in more trouble. If depending on the rocks, how hard the rock is, and then you have an actual, you have, while drilling, you have to use a specific fluid for that, so that you need a lot of things, lot of techniques, but still all those costly. So you have to weigh your economics, because drilling means more time. Blasting means you can do you can cover a larger area within no time as compared to drilling. But again, you have to see that. Now, I have seen that drilling while during Jeddah, and they were laying that railway track. It's a very lengthy process, this drilling or every time. But they cannot help it, because it was near to Makkah, and it was from Jeddah, and there are heavily places, heavily populated places around that. People are coming all around the world, all times in the world. People are coming for this Hajj and the Umrah. So that, and there are many people around it. So they have to be very precise, and that's why they cannot take the risk of blasting. But even with the 15 kilometers, 20 kilometers radius, you can still feel those drilling noise within the Haram Sharif as well. So such is the impact of those noise. So if you have an open space, you try to forget this. It has a very bad noise impact on your ears. Now, when we are now discussing the blasting, it is important that short layout means the places you are going to place your detonators should be properly engineered, documented, and adhered for a maximum consistency. Not only it's dangerous, but if you vary the short patterns, if you vary the distance, you can mean change in the product size throughout the operation. That's another thing. Smaller short rocks result in less crushing in the secondary and tertiary stages, means less improvement through crushing. If you have mineral quality and physical properties, product may be affected. This drilling I was referring is just like inserting your drill bit into the rock, and then it is turning into rubbles, and then it is being transported to the haulage trucks. But now again, the process is a very, very lengthy, and it's under this you can see some pictures of blast that is taking place for producing a rock. Now, when we see a short rock or gravel bank, a constant problem of a gravel pit and a quarry operator is the difficulty in maintaining uniform load from either the short rock pile or gravel bank. Even the best shot will have some variation from side to side and from front to back. Only and well experienced and well-trained equipped operators can accomplish the mixing from around the shot for the most uniform feed to the aggregates. Most uniform feed to the processing plant. For short rock, subsurface sampling and testing are needed to inform gravel pit managers where the size of the material changes. In many cases, for example, material from both above and below ground water levels blended in a prescribed manner to uniform feed to the plant. Then there are loading quarry trucks. Once your materials is there, you have to load it to the truck and transport to the some site where it is being processed for further production or for further use. This is how you can see in a picture how these sand and gravel excavations are taking place. So when we say blasting, it's a geological variability in deposit can sometimes affect sizing, but more often it will cause a change in mineral integrity. If a large variation exists, it may necessitate separating some products at later stages. Moisture variation in short rock can also cause significant problems. It is important that short rock moisture be monitored because significant changes will almost always require changes in downstream processing. If you think I can have better explanation, unfortunately not, because those who have an practical experience, there are not many people have achieved this technique. It's totally a different engineer. You need mining engineer for that. There's specialized field of engineering. It's not every civil engineer can be very good at blasting, and that there are I feel that that's why the specialization of mining engineers come along. It's not easy to explain blasting. It's a science, an established science that this has to be merited. So this comes under mining, this short blasting. Obviously, we are interested in the end product. Then comes the crushing. Once you have transported your rock, you have to crush it to your required size. The first step begins after the extraction from the quarry. Many of these steps also common to recycled materials, clay, and other manufacturing goods. The first stage is most operation is the reduction in sizing by crushing. Some operations, however, provide a step prior to crushing called scalping. Scalping means, what I mean if I ask you was what scalp, picking the things, right? Separating the stones at their side as well. Because you are not going to, break a chunk of a rock. You have to further process it. So there's some scalping is also required. So you see, scalping most often is used to divert fines at a job primary crusher in order to improve crusher efficiency. In this way, the very coarse portion is crushed and then recombined with portion of crusher run material before further process. This first step may, however, be an excellent time to deal with the deleterious problem. If a deleterious or fine problem exists in finer fraction of crusher run material, namely clay, shale, finely weathered materials, the full fall of Fall through of the scalping operations may be totally or partially diverted and wasted. In many cases, only acceptable amounts should be returned back to the higher quality product. Consideration processing variable in this stage can be very important. This is how scalping is done. You see, the big rocks are being separated. Just like, sieving like that. Then we come to the, when we say crushing, this can be done using these types of crusher. Each of that crusher has its own limitation, its own advantage. Over the years, people have found these, standardized crusher, and it doesn't mean you can use either of that crusher, depending upon your required for the product, and then sometimes depending upon the availability of the expert as well. And this also comes from your judgment. So when you are talking, the first thing, when the primary crushing is means, once you have blasted the rock, you have, drilled the material, and you have transported to the site, the first process is the primary crushing. Do you say there will be secondary or tertiary crushing? Yes. Primary crushing will not solve all of your problem. It may solve some of your problem. Then you need further crushing at the other end. So as a first step, there is a gyratory crusher or jaw crusher, and then there is impact crusher. These are most commonly used. While you see this, then you have to search pile. Then you have a secondary and tertiary crushing. That's a cone crusher and a roller crusher. This is a schematic of a jaw crusher. As you can see, this jaw is like the jaw of an alligator, crushing everything inside it. So it's usually you have to fill that material, and with this crushing, you use the jaw. You look at this. Don't you feel this is an eye of an alligator, right? And the material is being dumped, and it is crushing out of this thing. Material are sliding, and it is crushing, and it is going down. Seldom is a material that could not be crushed. Larger rock, it should cross these jaws. These jaws are continuously closing and opening. This is a large material, usually reduced in size by a jaw or gyratory crushing. Both are compressor crushing. They tend to create their thin elongated particles. This is the problem. Thin elongated particles are actually not specified by the highway agencies. So if you are using this jaw crusher, there are risks that you may produce some of the aggregates that are very thin elongated. They are not allowed in your, in any layer of an asphalt pavement, be in a base layer, be with sub-base layer, be mixing with an asphalt. No, you don't need those materials. So this is a disadvantage. Then there comes a horizontal shaft impactor. You see, it's just like a shaft. If I ask you shaft, something that is moving round and round, right? So this you're pulling up, introducing that material, and this are going down the machine, and horizontally it's being rolled and being broken into the pieces. Now this is a search pile in which what are you doing after crushing? You are storing it someplace, right? Storing it in a heap. This is what we call a search pile. So you have done the process. Once you have got this thing, now these are stored in this manner. These are being piled up, and then it is being transported for secondary crushing. First, it is stored there. And bulk of things, you can see the heap of materials that's there. Then there is a cone crusher. This is, you can see so there is a roller crusher. There are rollers, and you are passing the aggregates, and you are getting the aggregates from this. And there is a cone crusher. So these are again the other types of crushing the material to their size. Then there is a crusher fed system. I think I'll stop here and we'll move, we'll discuss this thing in detail tomorrow.